Okay, here we go. We are doing Unit 3, Lesson 1. I'm going to actually start with the cooldowns going forward, just because I know they're so important, and you all should know by now that those are on the quizzes. So the same questions you see on the cooldowns are on the quizzes. So we're just going to start there. That way, when you're going to search for study materials with the video, you can just go straight to the beginning of the video. So anyway, lesson 1, scale drawings, cool down, match the scale factors. So we got to match each image, there's 5 of them, to your answer key right here. So let's just knock out like the easy ones real quick. There's going to be a formula that we're going to use for all of these. And I just like really want to emphasize just how important this formula is, because it comes up so often, not only for Unit 3, but also Unit 4, Unit 5. We're really going to build on this formula. And the formula is this. It is A times, I'm just going to put this in parentheses because it's so important, your scale factor equals A prime. So A times your scale factor equals A prime. All right, so it's basically the pre-image, like FG, times the scale factor equals the image, which is the copy. And there's a prime here, there's primes here. So that's how you know which one is the original and which one is the dilated version. So I shouldn't say copy. This is the dilated version, and this is the original. So A times your scale factor equals A prime. All right, so let's knock out the easy ones real quick. So 3 is pretty easy, 5 is pretty easy. Now, based on what we just talked about, that means that FG is the original, or the, to use a proper term, pre-image. So all you got to do is just plug these in. So 12 times what, so the original times what equals 12. 12 times what equals 12? 1, right? And there's A, which is 1. So to go from this to this, you just multiply by 1. So the scale factor is 1. So on here, you just say A. All right, let's go to the next easy one. I think image 5 is pretty easy. So you start with 12. You multiply by some scale factor to get the dilated version, which is 24. So 12 times what equals 24? Well, 12 times 2. So this one is C. Now the next easiest one is here, image 4. So we start with 12, but this time instead of like going bigger like this one, we're actually going smaller. And specifically, we go from 12 to 6. So you can think of it like this. 12 times what equals 6? So again, 12 times what equals a 6? Well, 6 is half of 12. So 12 times 1/2 equals 6. So this one's E. Which means we're left with these two, 1 and 2, the hardest two. So let's start with number 1. A times your scale factor equals A prime. So 12, your original, times your scale factor equals 18. We're trying to solve for this scale factor, so divide both sides by 12. These two 12s cancel out. So your scale factor now equals 18 divided by 12. Let's pull a 6 out of each. 6 goes into 18 3 times. 6 goes into 12 2 times. So this is fully simplified. And when you just check your answers, oh, there it is, B. So number 1 is B. Now let's do number 2. Same thing. A times scale factor equals A prime. Starting with 12 times your scale factor equals 8. Same thing every time. Isolate the scale factor by dividing by 12. You're going to get something like this. Scale factor equals 8 divided by 12. Now you think about what goes into both 8 and 12. 4 does. So 4 goes into 8 2 times. 4 goes into 12 3 times. So 8 over 12 is 2/3. That one is D. And we're done. BDAEC. BDAEC. All right. Cool down's over. Now let's open up to page 6. I'm going to go kind of fast on this. We got a meeting in like 7 minutes. So let's see if I can do all the lesson in 7 minutes. All right, this one's easy. Let's make a scale drawing. Okay, cool. Here's the original hippo. Here's A and B. They ask us a question. Diego took a picture of a hippo, and then he edited it. Which is the distorted image? Obviously, A is distorted. Distorted means like stretched, basically, or just kind of like altered. Well, altered's a bad word, but stretched is a good synonym for distorted. And how can you tell? Well, A is not the same shape as the original. We're just thinking about shape. Now, B is the same shape, but A is not because it's been like stretched out. Is there anything about the pictures you could measure to test whether there's been a distortion? Yeah, like really anything. So, let me get some colors out. So we'll just go green and blue's good. Yeah, all right, cool. So why don't we go green and blue? So you could measure like the nose, the nostrils. And what you're gonna find is the ratio of the blue nostrils. So the big nostril divided by the small blue nostril, blue and blue, is going to be the same as the big green nostril divided by the small green. So that's just one example. You could measure really anything. You can measure the length of the legs and compare it to the length of these legs. So there's a lot of things you could measure. All right, let's do the sketching, stretching, and then I think I'll have enough time, just barely. So a dilation with center O and positive scale factor R takes a point P along the ray OP to another point whose distance is r times farther away from O than P is if r is less than 1. Viewpoint is really closer to O, not farther away. Okay, we're gonna get a lot of practice with that. We'll talk more about this throughout the unit. In the interest of time, I'm just gonna show you some examples. So to dilate something, think of like a movie theater. Like you got a movie theater. That's actually like a tiny little film strip that's projected onto a giant movie screen. So dilation is, you're gonna end up having a center and a scale factor. So in this instance, C is your center right here. And they're saying your scale factor is 3. And that H is 40 millimeters away from C. If our scale factor is 3, we essentially got to triple this. So I'm going to say H is going to be over here. And we're just going to triple check and see how well I did. So they told you H is 40 millimeters, actually 35, believe it or not. But the book will do that sometimes. So this would be 2 times as big. And this right here is actually the one we want. So this is H prime. So my estimate was a tiny bit off. So here we go. Let's just redraw this a little bit longer. So there you go. There is H prime. And if C to H is 40, this would be 40, this would be 40. What is 40 times 3? Well, that's 120. All right, dilate K using O as the center, scale factor of 3/4. So this time O is the center. So O is the center, meaning it stays put. K is 40 away from O. But the scale factor this time is 3/4. So you got to say like 40 times 3/4 equals OK prime. So let's just do it real quick. Believe it or not, it's actually 35, which makes it real fun. That's a lot. So 40 times 0.75 equals 30. Let's see what 35 times 0.75 is. 26.25. So I gotta go right. Let me see here. So hang on. There's 26.25. So this is where K prime is going to be. Now, they told you it was 40 from O to K. Scale factor of 3/4. So you just go, this is just A times scale factor equals A prime. So this is going to end up being 30, O to K. All right, I'm going to run out of time here, but here we go. I've got this protractor. I need centimeters. Phew. I know I'm gonna run out of time. I have a meeting at 8:30. Oh well. All right. Let me check. Actually, I might not start till 8:45. Hang on one sec. Sweet. I have 15 minutes. What do you know? All right, cool. So, here's what we're gonna do. This is the snowman. I love the snowman problem. It's so fun. So, what you have to do here is you have to measure from P to each point. So, the points are A, B, C, D, E, F, G, H, I, and J. So, you gotta measure from P to every single point. Now that I got a few minutes, I can kind of relax. But what we're gonna do is we're dilating this, I'm calling it a snowman, looks like a snowman to me, using center P and scale factor of 1/2. So don't forget our formula, A times scale factor equals A prime. A times scale factor equals A prime. So what you need to do is measure PA, PB, PC, PD, PE, PF, PG, PH, PI, and PJ. So here we go. We're gonna do the name of the segment, the length of the segment. We're gonna multiply by 1/2 for all of these. And then we're gonna have a new length. So this is basically gonna be A, this is your scale factor, and this is A prime. So A times your scale factor equals A prime. Okay, I'm gonna show you how it works. We're gonna go in order. So P to A is 12, just a little bit more than 12 centimeters. So A prime is just gonna be like right there, just barely past 6. So we're gonna call this A prime. And it's on the same ray, or the same line segment as PA. All right, let's go to B. P to B, we'll say 12.1, ends up going like 6.05. So P to B is 11.8. So PB, 11.8 times 1/2, 11.8. 11.8 times 0.5, it's the same thing, is 5.9. So 5.9 is right there. So you're gonna have B prime right here. Okay, so that's 5.9. All right, let's go P to C. P to C is, let's get that right, 13.2. 13.2, P to C. 13.2. What's 13.2? Divided by 2, same thing as multiplying by 1/2. It's 6.6. So P to C needs to be 6.6. No problem. There's 6. There's 6.6. There's C prime. Okay, P to D is 13.567. 13.7. Actually, let's just say 13.8. So P to D is 13.8 times a half. So 13.8 divided by 2, 6.9. I need D prime to be 6.9, which is right there. That's D prime. Okay, whoa, they're all in line. Weird. So are these. Okay, let's go to E. So E to P, or P to E is 14 point, looks like 14.4. 14.4 times a half, right? So 14.4 times a half is going to be 7.2. 7.2 is right there. That's going to be E prime. All right, let's go P to F. 15.6. 15.6 times 1/2. 7.8. P to F. It's got a F prime's got to fall on that line. 7.8. All right, there's F prime. Okay, let's go P to G. Paul George, great NBA player. Here we go. We're gonna say that one is 15 point, looks like 15.9. Let me just double check. Yeah, 15.9, P to G. Times that by a half. 7.95. So P to G is 15.9. So we're going 7.95. So right there. There's 7.95. And that's G prime. Okay, let's go P to H. That's like Pleasant Hill. What a cool city. Pleasant Hill is 10.4. 10.4 times 1/2 is 5.2. There's 5.2. That's going to be called H prime. Got 2 more to do. P to I, pass interference, is 9. So we got to go to 4.5. 4.5. That's I prime. So P to I was 9, so half of it, 4.5. Last but not least, PJ. PJ Tucker. He's an old veteran in the league. Good role player. Plays with a lot of heart. We're going to say 8. There's 5, 6, 7, 8.75. So 4.375, 1, 2, 3, almost to 4. Boom, there it is. And that's J prime. So you got all these points. I'm just gonna draw them a little bit bigger. And now you gotta connect them, just like they do. So G to F. Gotcha. E to F. There we go. Sorry. Not as precise. Okay, let's go. H to I. Let's go I to J. I to J. Okay. Now we got A to B. That's obviously the radius. So I'm gonna just set a compass real quick. Really try to make this precise. Okay. Make sure it looks good. Okay, I think we're good. A to B. Tend to get off on my H. Draw your points real big to make up for that. Something called human error. All right, and then we're going C to D. Looks like I might have made one more mistake, but that's okay. These mistakes are fun. All right. Who's Bob Ross? There's no mistakes, just happy accidents. I think C is a little bit. Must have made a tiny little mistake there. That's fine. What do we do? That's more like it. Oh, jeez. It's not the greatest. But what you're going to find is we made I'm going to call that C prime. Little adjustment there. But we got this snowman now. Little guy. So what you're gonna find is the blues, the ratio of the circles from this to this. This circle is gonna be twice as big. This circle is gonna be twice as big as this one. Let's look at the green ones. Gosh, I don't have much time. Got a meeting in 2 minutes. I still have to do something too. Oh well. But we gotta get these videos recorded. So what you're gonna find is the circle ratios here. And we can even do this one. The circles big divided by small will be the same thing you're going to find the ratio of the big to the small is going to be the exact same for both of those. And you can tell exactly what it'll be by the scale factor. This is going to be twice as big as this. This green one's going to be twice as big as this. Crazy observation that a student made yesterday, which I love, is that the radius AB ends up being the diameter of this one. So from here to here, there to there, is the same length as there. This is a diameter, this is a radius. I thought that was a really cool observation. Anyway, John Snowman, what do you wonder? Come ask me, I'll help you. If you have any questions on this, it's a cool problem, and I really gotta go. All right, see ya. Hopefully that helps.